Welcome to the React Monorepo tutorial for NX. In this tutorial, we'll be creating a monorepo from scratch, using all the recommended features of NX. When we use all these features together, we call this style of repository an integrated repository. So what an integrated repository is, instead of linking projects together with NPM workspaces, we'll use TypeScript path aliases to import local projects as if they were NPM packages. We'll maintain all of our dependencies for the repository in a single package.json file at the root to help avoid version conflicts. And we'll use NX's generators to quickly scaffold out code for ourselves. Now, during this tutorial, we'll create a React application, learn how to run tasks, cache tasks, and set up task pipelines so that dependent tasks are always run in the correct order. Then we'll create separate libraries that the application can use and create a second application that can easily share code with our first application. We'll set up some rules for how these projects can depend on each other, and finish off showing you how to dramatically speed up your CI pipeline. Alright, enough talking, let's get started. To generate an NX workspace from scratch, we'll use the npx create NX workspace command, and we'll use the latest version of it, and we'll call this folder React Monorepo. And NX provides several presets for you. We'll use the preset React Monorepo to spin this up. We'll call the first application the React Store, and we'll use Vite for a bundler, Playwright for our test runner, and CSS styles are fine. Let's choose yes to enable NX Cloud. We'll explain more about what NX Cloud does for you a little bit later in the tutorial. Now let's open up that folder. Once we've run this command, you can see that the folder structure looks like this. We have an apps folder with the React app that we created called React Store, and set of end-to-end tests written with Playwright here, and configuration files for ESLint, and Prettier, and Jest. To serve your React app, you can just run nx serve react store. Now nx is a CLI command, and you can run it by running npx nx -- version. Now if you don't want to always prefix it with npx, you can install it globally with npm i-g nx. Once that's done, you can just type nx -- version. Now in order to serve this React app, we can just run nx serve react store. And there you see your React app is running in the browser. Now for every task that NX is aware of, you can run them with NX space, the name of the task, and then the name of the project. This would work the same for NX build, or NX lint, or NX test. Let's see all the tasks that NX is aware of for the React store. We'll run NX show project, React store. And you can see that NX knows how to use Vite and ESLint and Jest to run various tasks on this project. Let's take a look at the build task. You see here that this task was created by the NX Vite plugin by inspecting this Vite config file that we have in our React store. NX will run Vite using whatever configuration settings you have set in your Vite config file. Now this outputs folder here is stored in a cache every time you run the build, so that anytime you run the build with the same input files, instead of recalculating the build, it will just pull those files from the cache. And this value is not hard-coded here. It's actually calculated based on the configuration settings you have in your Vite config file. Let me show you how that works. So if I run nx build react store, the first time it takes a few seconds, and if I do it again, it completes instantly. It also says that it read the output from the cache. Now even if I delete this dist folder and run it again, that dist folder gets recreated and it used the cache. Now what happens if I want to store my output for my build in a different location? We'll scroll down to the build property here and set our out directory to, instead of outputting to the workspace root, we can set it to a local dist React store folder. Now if we look at the project details again, we can see that the outputs have been updated to match what we have in our configuration file. And if we delete our dist folder in the root here, we can run the build again and see that it made the dist folder in our React store folder. Now if we delete it and run it again, it'll replay it from the cache. Now NX also provides generators that allow you to scaffold out code quickly and easily. Let's take a look at what's available to us from the NX React plugin. We'll run NX list NX React, and you can see here there's a whole list of generators that can help you create more code in your projects. We'll use the application generator to create a new application. So we'll run NX generate, and the name of the plugin, and then a colon, and the name of the generator. We'll call our application inventory, and specify the directory we want to put it into, the apps inventory folder, and we'll use the dry run to make sure that it creates the files in the place we want them to. We'll skip the React router, we'll use playwright, and we'll use that name and directory. Great. So this runs the generator without actually making any changes to your file system and shows you which files are created or updated. This looks all right. So we'll run it without the dry run flag and actually make the file changes. No React router, playwright, and just like that. So now we have an inventory application and a React store application. Now in order to share code between these applications, we can create local libraries that contain that bits and pieces of code. Now local libraries are very useful not only for sharing code between applications, but also to set module boundaries between how these projects depend on each other, to have some separation of concerns, to split up different domains of knowledge in different areas. In a typical monolithic kind of application, you might have all your features or your routes set up in different folders inside of this source application folder. But we recommend splitting out those features or routes into separate libraries so that you can more easily share that code and kind of manage how that code interacts with each other. All right, we'll create 3 libraries. I'm just going to paste in the commands. We'll use the same generator syntax that we use for applications. We'll create libraries that are named products, orders, and shared UI, and we'll put them in separate directories here. Now we have a new libs folder with orders, projects, and a shared UI folder here. Notice how UI is underneath the shared folder. You can set whatever folder structure you want. It doesn't even have to be under libs or apps. You can split these out in whatever directory you want to put them in. We could call these modules or packages or whatever naming structure you want to have for your organization. Now, each of these projects has its own tasks inferred for it based on the configuration files that are set up. So the vconfig for building and testing with vtest, and a lint command because of the ESLint file here. And you have a projects.json file where you can customize, add your own targets, or overwrite the existing targets with your own settings that you want to put in there. Notice the name here matches whatever name you specified in your generator command. You can also see inside the source folder, this index.ts file is the public API for this project. So anything that's exported from here is publicly available to be used by other projects in the repo. If you don't export a function or a variable from this index.ts file, it will throw a lint error if some other project tries to reach in and use that code that you did not intend for other projects to use. You can also see in the tsconfig.base.json file here, there are some paths set up for each of these libraries so that they can be referenced by other projects. So let's look at the products project here, and we see that we have a products component created here. Let's use that products component in our main React store application. Let's first add the React router. We'll do npm add React router DOM. And then we'll set up that React router in the main.tsx file. So we're using the browser router here and configuring it here in the root. And then we'll go to the app.tsx file and we'll use that products component with the React router. So we can see here that we're importing products from the products library. And then all we need to do is use that products component as we would any other component. We can serve this app and see that it's using the products component. So if we go to the /products URL here, we'll see our products component is displayed. We can also do the same thing for the orders component here. We'll import orders from the orders library and use it under the orders route. And let's also use products in the inventory application here. Now, NX is able to automatically understand the way your projects depend on each other. And it creates a graph of how those projects are connected. So let's use the NX graph command and see that visualization. If we click on the show all projects, you can see that the React store depends on products and orders, and the inventory store depends on products. Notice here that shared UI is not being used by anything. And this is because we have no import statements that go from another project into shared UI. So this line here is being created by that app.tsx file that is importing orders from the orders project. Similarly here, the inventory app is using the app.tsx file, is using an import statement to get the products component from products. Now, as your repository grows and changes, this graph will continue to grow and change itself. NX will always have a completely accurate understanding of how your projects really depend on each other, not just the way you wish they depended on each other. Now, I showed you before how to run an individual task like NX test React store, you can run multiple tasks at the same time by passing multiple tasks in this -t flag. So test, lint, and build. You can see that 2 of these tasks fail, the test for React store and inventory. This is because we changed the code without changing the unit test. Now for this next step, we'll commit our changes first. We'll do git init to set up a Git repository. We'll add the changes and then commit them with a message. Now let's make a small change to the products library. We'll add some text here. Now one of the key features of NX is that it's able to run the tasks for only projects that have been affected by a particular change. So let's run the NX affected command and then tell it which task to run, just the tests. And what this will do is run the test tasks for any projects that have been potentially affected by just the change that I made to that products library. So there are 3 projects that were affected, and it ran the test task for each one of those. If we run the nxgraph -- affected command, we can visually see which projects are affected. Here it's showing all the affected projects. If we show all projects here, you can see that the affected projects are in pink here, and the unaffected projects are in gray. So if we change products, we need to test the inventory and React store application as well, and run the end-to-end tests. But the shared UI and orders projects, there's no possible way those projects are affected by any change we make in the products project. For this small of a repository, it doesn't make that much of a difference. But the more applications, the more libraries and projects you have in your repository, the more of a difference this makes in CI. If I'm only changing this inventory application, I don't want to run the tests and the build for every single application that I have in this repository. Now let's say you want to deploy your application to production. We don't have an inferred task already that's set up to do that. So we'll go into the project.json file for the React store, and we'll create our own deploy task here. And we'll set it up so that it depends on the build. So anytime you want to run deploy, you have to run the build first. And we'll just specify a command in here, whatever command you run to deploy your application. In this case, we can use netlify and the deploy command and pass in the directory that the build outputs to. Now, if you want to deploy all the applications that have been affected by a certain change, you can run nxaffected -t deploy, and this will run that deploy task for any project that has been changed in a particular PR. And if you want to change the logic to deploy any project that has been changed since the last time you deployed, you can use the -- base argument here and pass in the commit or the branch that was used for that deployment. This will compare the Git history between the commit for production and the commit that is currently on the main branch. And any projects that have been affected by any change that has happened in the meantime will be deployed. Okay, now let's talk about code sharing. It's great to be able to easily reuse code across your code base, but sometimes that can get you into problems. We want to have some structure around how code is shared so that people are not reusing code in places where they shouldn't be using it. For instance, it's probably okay for orders and products to use code from the shared UI library, but we probably want to restrict the shared UI library from using code in the orders or products library. And maybe orders is allowed to use products code, but products is not allowed to use orders code. So we can set up these kinds of rules using a tagging structure for applications, and then we can use those tags to define rules about how these projects can depend on each other. So if we go into the project.json file for each of these projects, we'll add some tags to this orders library. We'll give it a type of feature and a scope of orders. These tags are just strings. You can have them be whatever strings you want. This is just one way of doing it. The products library is a type feature and scope products, and the UI library will give it a type of UI and a scope of shared. So to enforce these rules, we'll go into the root eslint.rc.json file, and we'll modify these dependency constraints here. I've pasted in these changes here, and you can see that this rule says that features can depend on other features and UI libraries. UI can only depend on other UI libraries. Orders can depend on orders, products, or shared. Products can depend on products and shared can only depend on shared. To test this out, we'll go to the products component here, and we'll see if we're allowed to import from the orders library. Now here we have a lint error saying that the project tagged with scope products can only depend on libraries tagged with scope products or scope shared. So this is blocking us from importing where we shouldn't be importing. Now you've seen how NX can benefit you in your local development. Now let me show you how you can dramatically speed up your CI process using NX Cloud. We'll use a generator to generate a CI workflow and specify that our CI provider is GitHub. Now this creates a ci.yaml file here, and it uses this NX affected command to only run the lint test or build tasks for the projects that are affected by a particular PR. You can commit this and run it in CI. And once you're set up with NX Cloud and you've registered on nx.app, you can uncomment this line here, which will enable you to automatically run your entire build system on multiple virtual machines. We'll automatically create these virtual machines for you, these agents, and distribute the tasks across as many agents as you specify here. So if your CI is taking too long, all you need to do is change this number here from 5 to 8, and now your task will be distributed across 8 machines in the most efficient and fast way possible. So this leaves you in control of how much compute you want to use and allows NX to automatically optimize the CI process for you. You can change this number up or down as much as you want. And NX, because it knows the graph of how your projects depend on each other, will automatically run the tasks in the correct order and then replay the outputs of those tasks onto a single machine so you can debug your run all in one location. Now these are just a few of the features of NX. If you want to explore more, go to nx.dev and explore all the things that NX can do for you.